Hello, my name is Elena and I am a researcher at the Italian Institute of Technology. And today I will be talking about robots and about engaging them to the point of interacting with us and as another human would do. First, I realized that in addition to other skills such as object recognition or their ability to move, one aspect that was crucial was their social intelligence. Because how could we aim to build agents unable to perceive and act upon our emotional states? However, as it is still unknown how many emotions are there or how people respond and behave when experiencing most of them, social intelligence has become a very complex skill and feasible to be modeled and integrated in robots as a whole. Therefore, instead of approaching all the individual aspects of social intelligence, my team and I came up with a single representation that would focus on real-time interactions. And we came up with comfortability. We define it as you can read here, but basically it represents whether someone is okay or not with the actions their interaction partner has conducted, independently of the specific internal states they might be feeling at the same time. For example, the people in this picture might feel a lot of internal states, relaxation, joy, engagement, and so on. But to know if we, as communicators, are proceeding properly, we don't really need to know all their specific internal states, but their desire to stay with us or to go. And as humans, we apply this knowledge continuously because in case our inner classifier detects someone has gone wrong and someone wants to go away from us, we can be conscious and try to fix it, or at least we can learn from the experience and avoid performing and creating the same circumstances in the future. In the same fashion, this project aims to create robots with the same skill, so they might build smoother interactions with humans. As a consequence, this paper presents the first model capable of classifying high and low comfortability better than chance. The system has a peculiarity that has been trained with videos recorded from several human-robot interactions. Concisely, 29 researchers were interviewed by ICAP, the robot you can see here, for a real column of our magazine. Thus, the data, apart from being diverse, is spontaneous and genuine. Let me show you a glance of it.
Ciao ICAP.
Hello. Thank you very much for participating. I am very happy that you are here.
And there is no time to show you all, but I will summarize it. During these interviews, I got asked a lot of questions, and they were about their personal life and professional career, but all of them were with the intention of making them feel comfortable, for example, by complimenting them. For example, there was one question in which I kept asked them about their hobbies and then told them, "Whoa, I think you are very cool." And also to make them feel uncomfortable by ignoring, misunderstanding, or insulting them. For example, ICAP made them repeat 4 times the reasons why they thought they had the courage to pursue their dreams. Each interview was done with one participant at a time, and the videos lasted an average of 18 minutes. Each video was streamed into 24 segments, each segment representing a specific question of the interview. And last, each segment was streamed again into several clips of a 3 seconds duration, and this is the usual time a macro expression might last. As a result, 8,467 clips were subsequently analyzed. To create a stronger set of annotations, I personally analyzed the dataset twice. Each clip was labeled with a 1 out of 7 possible comfortability labels from extremely uncomfortable to extremely comfortable. I used the annotation platform Mobile app where I could see a single clip of 3 seconds without audio and a 180 resolution played in a loop until I decided the label, and then I could move to the next one. As a result, I perceived 49% of the clips as uncomfortable and 51% as not uncomfortable. That is to say, being either neutrally or highly comfortable. To fit the models, the clips were pre-processed into several combinations of different facial and upper body features. 34 features represent 17 action units, 48 associated to the person's upper body, 16 to the person's gaze, and 20 to the head location and rotation. All of these features were collected either with open face or open pose. In all the cases, all the extracted values, either positions or intensities, were averaged per clip. And this way, each feature was either the mean or standard deviation of such values, with the exception of the head pose, where also the velocity and accelerations were included. This leaves a total of 118 features used for training. All the possible combinations of the features mentioned above were fed to all these 4 possible algorithms. The results shown in this table include the combinations that worked better for each one of the algorithms, that is to say, the models that presented a higher accuracy with the training set. In general, we can see that all the algorithms performed well, as the testing and training set accuracy is above chance levels. A combination of all the features together, trained to a random forest algorithm, has proven to obtain the best training and testing results, obtaining a 100% and 75% accuracy. We can also see this from its confusion matrices, either from the training and testing set, that most of the clips were classified properly. Even though the clips of the testing set were unknown to the system, the participant might have not been. Thus, we train again all the models, but this time leaving one subject out and averaging the results. With this new approach, the accuracy dropped from 75% to 58%, which is still acceptable for faces never seen by the model. We believe that in order to improve this, the system would need to be trained with a much wider dataset. And at the end, this paper has presented the first system capable of recognizing comfortability, and it has achieved a 70% accuracy recognition. We acknowledge that this is the first step, but we believe that necessary to achieve socially intelligent agents. And this is my team in Genova, which has helped me to achieve this project and goals. And this is my email. Please write me if you want to know more about the project. And thank you very much for listening.